All right, so this is literal equations part 2. Like I said, we're going to do a couple videos on this. This is a lot of stuff. And this is a big thing, solving literal equations, solving equations with a bunch of variables. This is something you're going to be doing a lot in part 2. All right, so this is 2.7 literal equations again. But now we're going to look at another scenario of what happens. But before we do that, we got to look into what's called factoring, right? Or undoing distribution. Okay. So how I lead into this, we're going to look at these examples here in a second. But how I always lead into this is if, say, I had 4 plus 8, right? We know 4 plus 8. We know that is 12. We're like, yeah, Mr. Harris, what does this have to do with factoring or undoing distribution? Well, what is a common factor of 4 and 8? What number can I multiply both of them by? Or what number are both of these divisible by? Well, let's go with 2. So if I factor out a 2, or if I take 4 and I divide it by 2, well, what times 2 will give me 4? Well, that would be 2. So if I did 2 times 2, that'll give me 4. Well, then what times 2 will give me 8? Well, that'll be 4. Because 2 times 4 is 8. Now I have this. Again, undoing distribution. If I distribute this 2 through, 2 times 2 is 4. 2 times 4 is 8. We ended up with the same thing. So by doing this, I look to see what's common between both of these things. And you may be going, okay, Mr. Harris, why are we doing this? What does this have to do with anything? Why don't I just do 4 plus 8? Well, because sometimes we can't do that. So let's look at this first example here. We have 4x plus 3xy. Well, I can't combine these. They're not like terms. Well, does each part have something that's very similar, that is the same? And yes, they both have an x in it. So we're going to take that x out. We'll draw our parenthesis. So what times x will give me 4x? Well, that would be 4. Because as you can see, I took the x out. X times 4 will give me 4x. Plus, I'm going to bring down the same sign. I took the x out. What's left over? 3y. Because 4 plus 3y, if I distributed this x through, I'd get 4x plus 3xy. That's what I'm doing here. I'm factoring, right? I'm undoing distribution. It's like, hey, this is my answer. What's the question to give me it? It's like Jeopardy. Jeopardy gives you the answer. You got to figure out what the question is, right? And that's what we're doing here. Here's the answer. What's the question? What would I distribute to get that? You can always check by distributing. Let's look at another one. And this one's kind of tricky. Think of the 4 plus 8 example that we did. Well, what's common between both of these? Well, we know there's an A, right? We know there's an A. Well, let's look at the numbers too, 12 and 4. Is there a common factor, a common number that both of these are divisible by? And I know a lot of you thinking 2. Well, there's a bigger number. What would be that bigger number that are both divisible by 4 and 12? Well, that would be 4. So then if we look, okay, now we got our parentheses, so we factored out a 4a from both of them. Well, what times 4 will give me 12? Well, that's 3. And I already took the a out. Plus, what times 4 will give me 4? Well, 1. Well, I already took the 4a out. What's left over? B. Boom. Undoing distribution. It's called factoring. Here's my answer. If I distribute the 4a to everything, I'd end up with 12a plus 4ab. And let's look at this one. This one's a little bit trickier. What's a common factor? Well, do they both have the same variable? No. Well, what are they both divisible by? 2? Yeah, okay. Is there anything bigger? 4? No, 10's not divisible by 4. 5? No, 8's not divisible by 5. 8? No, 10's not divisible by 8. So 2 would be the value we're going to factor out. Well, now what's left over? What times 2 will give me 8x? Well, that would be 4x. What times 2 will give me 10? Well, that would be 5. Boom. That's factoring. You may be going, why are we learning this right now? Well, we've been working with literal equations, and I know I said well about 1,200 times right there. We've been working with literal equations, and sometimes, so like back here, we were just solving, and sometimes we might need to factor before we can do anything. So let's look here. We have 7x minus 2z equals 4 minus xy. Well, we want to solve for x. So let's get everything with an x on one side. Okay. And ideally, I like to try to get the variable we're solving for on the left. So to do that, let's move anything with an x. So I got to move this xy, move this xy. These go away. So I have 7x minus 2z plus xy, because none of these are like terms, I can't combine them, equals 4. Now, this doesn't have an x in it, so I want to move it. Add 2z, add 2z. So 7x plus xy, again, these can't combine together. This has a y, this doesn't, equals, these can't combine together because this 4 doesn't have a z, so we have 4 plus 2z. Well, I still need to solve for x. Well, I could try to subtract 7x. Well, then I got, wait, move it. This is where now, as we can see, both of these have an x in it. We got to factor out that x. So we're going to factor out the x. So we have x times 7 plus y equals 4 plus 2z. All right. Now, hey, I need x by itself. We're going to divide by 7 plus y. Divide by 7 plus y. We can't do this math. So then we're left with x equals 4 plus 2z all over 7 plus y. X is by itself. We solve for it. We are done. All right. Let's look at another one. I know that was a lot thrown at us right there. Let's look at another one. We have 6a minus 18 equals ab plus c. Well, we want to solve for a. So we need to get anything with an a on the left side and anything without an a on the right side. Right? So let's look here. So let's subtract AB, because this has an a. We want to move it over to the left side. 6a minus 18 minus AB equals c. Well, this 18 doesn't have an a, so we're going to move it. Add 18, add 18. 6a minus, because this minus goes here, AB equals 18 plus c. All right, because we can't combine these because this doesn't have a c. Now we go, oh, I need something with it. Oh, they both have an a. See, we have an a right here. We have an a right here. So we're going to factor out the a, leaving me with 6 minus b equals 18 plus c. I didn't do anything over here. A is not by itself, so I need to divide by 6 minus b, divide by 6 minus b, and a equals 18 plus c all over 6 minus b. We solve for a. Boom. So these are just like these are just another version of literal equations, but sometimes we have to factor out the variable we're looking to solve for. So sometimes we will run into that situation right there. All right, and the last example I want to look at is something like this. So let's say I have I equals PRT, and this is an actual formula. This is interest equals principal times rate times time. So this is you take out a loan, a mortgage, whatever, anything like that. You borrow money, also your bank's going to collect interest and all that stuff. This is a formula they use, but this is simple interest. You'll learn more about those type of things in maybe like business class or something like that. So we want to solve for R. Well, if we look here, R is right here in the middle. Well, what's happening between the P, the R, and the T? Well, multiply, because when we have variables next to each other, it means multiplication. Well, if I want to get r by itself and everything else is being multiplied by it, what's really cool about this, doesn't matter order, to get rid of the other variables, I would just divide by those variables, p and t, because those go away, divide by p and t over here, leaving me with r equals I over p and t. So when we see something where there's a whole bunch of variables being multiplied by each other and you're solving for one of the variables, just divide by all the other variables. It doesn't matter. Let's say I have 5 equals A, B, C, D, F. And I want to solve for C. I want C to be all by itself. Well, because everything here is being multiplied, to do that, I would just divide by A, B, D, and F. A goes away, B goes away, D goes away, F goes away. Leaving me with C equals, well, then I got to do the same thing over here. A, B, D, and F. C equals 5 divided by A, B, D, and F. So when we see something where there's a bunch of variables being multiplied together and you need to solve for one of them, just divide by all the other ones. Real simple. All right. This one's just subtracting. You subtract A, then you subtract C. All right. So it shouldn't be too difficult. So that's my other video on literal equations, variables with multiple variables. Again, we're going to do a couple more practice with these. Again, this is a topic that we really need to make sure we hone in on. I know it's a little difficult. We're doing it over video versus you being able to come in and talk to me. If this is something that's really you're stuck on, feel free to email me. We can set up a video conference. All right. So let me know, like, Mr. Harris, I'm really stuck on literal equations. Boom, I'll be like, all right, let's set up a video conference. We'll do 11:43. All right, sounds good. Okay. No, there's not a video conference at 11:43. I just gave you an example. Take ownership of your learning. If you are stuck, we can set up a video conference. And even if there's multiple of you guys stuck, maybe we can try to set up at the same time. Okay. So good luck, and again, keep working hard, guys.